In this video, we are going to talk about translations on the coordinate plane. Let's begin. So remember, a translation is when you're changing something, and there are four kinds of translations. There's there is a translation, which means I am just moving it. There is a rotation, which means I'm spinning it around. There is a reflection, which is like a mirror reflection. And there's also a dilation, which means making it bigger or smaller. So the translation, we're going to focus on that one right now. And this is all about moving the image around. So a translation moves every point of a figure the same direction and distance. Direction and distance. So we're going to be translating shapes, not pictures of dogs or anything. A translation can move a figure left and right, left/right, and or up and down. Translations are also thought of as like to slide it. They call it slides, or sliding it left and up. So let's look at some examples. Translations are kind of nice. Quite easy. Translate the figure 5 units left and 2 units down. Record the coordinates of the pre-image and the image in the table. So let's record the coordinates first. A in the pre-image is point A is, let's see, it's this one right here, and that is 2 and 4. It's on point 2, 4. Let's do B and C as well while we're at it. B is 6 and 7, right? And C is 7 and 3. All right. Now, our new image, we're going to label it with a prime, so A prime. So what we're going to do is we're going to take our image, we're going to take each point of our image, and we're going to translate it. We're going to move it 5 units left and 2 units down. So let's take this. Let's go 5 units left, 1, 2, 3, 4, 5, and 2 units down. 1, 2. So right there. I believe. 1, 2, 3, 4, 5, 1, 2. Yep, right over here. And that's going to be our new A. We're going to label that A prime. And that is located at -3, 2. Might as well do B prime, C prime. Okay. So B, we're going 5 units to the left. 1, 2, 3, 4, 5, 2 units down, right here, right here. Right there is B, so that is located at 1, 5. I'm going to label that B prime. C, 5 units to the left, 1, 2, 3, 4, 5. Down 2, 1, 2. That looks like it's located at 2, 1. And then label it C prime, and then let's connect our dots. Right there. So it's a triangle, except we've translated every point 5 units to the left and 2 units down. Look for any pattern and describe what happened to the x, y values of each ordered pair. Well, I went from 2, 4 to -3, 2. 6, 7 to 1, 5, 7, 3 to 2, 1. Well, if I moved 5 units to the left, doesn't the x value, remember the left and right value, if I'm going 5 units to the left, aren't I just like subtracting this x number by 5? So 2 minus 5, does that equal -3? Yeah. X values decreased by 5, decreased by 5. And what happened to the y values? Well, if I went down 2, well then the y values decreased by 2. So let's see if that's true. So x goes down by 5. 2 minus 5 is -3. That's true. 6 minus 5 is 1. 7 minus 5 is 2. Yeah. Y, the y value is going down by 2. 4 minus 2 is 2. 7 minus 2 is 5. And 3 minus 2 is 1. How can we represent this algebraically? Well, if we take the x, well, let's do our ordered pair, our quotation mark or our parentheses, x goes down by 5, right? So we subtract 5. And y, well, that went down by 2, so we subtract 2. So that's how we represent it algebraically. When they want us to go 5 units to the left, take x, subtract 5 from it, take y, subtract 2 from it, and you'll figure out what your new ordered pairs are going to be. Let's try number 2, except this time, let's see if we can figure it out algebraically. So let's go ahead and write points D, E, and F. Point D is right over there. It is -7 and -4. -7, -4. Let's look at E now, which is right over here. That is -4, +1. Then let's look at F, right there. -3, -5. So -3. Okay, what do they want us to do to this pre-image? They want us to translate it 4 units right and 3 units up. So 4 units to the right, 1, 2, 3, 4, and 3 units up, 1, 2, 3. That goes right over here. 4 units right, 1, 2, 3, 4, 3 units up, 1, 2, 3. And that is our new D prime. Oh, you know what? Remember I said let's actually do it algebraically? 4 units to the right, that means x plus 4, right? 3 units up, that means y plus 3, right? The y value, the up and down, plus 3. So if I know that this is going to be D prime is -3, -1. So if I want to take x and I add 4, so -4 plus 4, isn't my new point going to be 0? And 1 plus 3, isn't that going to be 4? And that's going to be E prime. Let's see, let's try that, 0 and 4. So 0 and 4, and I'm saying that's going to be E prime. Let's see if that's true. If I take E, if I go 4 units to the right, 1, 2, 3, 4, and 2 units up, 1, 2, or 3 units up, 2, 3, yeah, that's it. It's exactly where I said it would be. So let's try that with F. -3 plus 4, well, isn't that going to be +1? And -5 plus 3, it's going to be -2, right? So 1, -2, that's F prime. Let's see if that's right. Let's see if I did it correctly. So 4 units to the right, 1, 2, 3, 4, and then 3 units up, 1, 2, 3. Yep, that's exactly where I said it would be, and it is. So yeah, if you do it algebraically, it works as well. So what happened to the x values? X increased by 4. Y increased by 3. So to represent it algebraically, we would say x increasing by 4 is +4, comma, y increasing by 3 +3. And that is how we represent a translation algebraically. Let's try 3 and 4. Record the coordinates of the pre-image in the image below. All right, the pre-image, remember, is the original, no primes. So H, I, J, A, B, C, F, E, H, G, H. So I guess G should probably go first. We're going alphabetically. G is 2 and -7. G, H, I, J. H is 2, -1. I is 5, -1. And J is, let's see, 5, -7. Let's look at the image. The image, G prime, let's actually put G prime, H prime, I prime, J prime. G prime is, let's see, -5, -3. H prime, -5, +3. I prime, -2, +3. And then J prime, that is -2, -3. Verbal description of the translation. What happened with it? Well, let's see what happened to H. It went over 1, 2, 3, 4, 5, 6, 7, left 7, 1, 2, 3, 4, up 4. Left 7, up 4. Algebraic representation. Well, if it's going left 7, that's like backwards, right? Backward 7, that's x minus 7. What's up 4 mean? Well, that's y plus 4 more. So y plus 4. What do you notice about the line segments in the pre-image and the post-image? Do they change size? No. This is considered a rigid transformation. The transformation is rigid. It hasn't, the size and the shape has not changed at all. Let's try this next one, number 4. The original is right up here. I might as well highlight the original, right? And then let's go to the new one. So let's record the pre-image. J, K, L, M, N. So K, L, M, N. Looks like K, right there, that is, let's see, -7 and 2. JKL, -2, +2. M, -2, M, sorry, -2, 7. And N, that is -7, +7. Let's look at the image now. The image is, let's do K prime, L prime, M prime. That's an ugly M. Come on. M prime, N prime. All right, K prime, that is 2, -7. L prime, down here, that is 7, -7. M prime, that's 7, -2. And N prime, that is 2, -2. Verbal description of the translation. Let's go from K to K prime. So what I do, I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 to the right, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 down. Algebraic representation. Well, I could have figured that out by looking at this as well. The x, what's happening to the x? It goes up, right, from -7 to 2. Oh, up 7 means plus 9, right? Which is right to the 9. Let's look at y. What's happening to y? It goes from 2 to -7, so it's going down. So it's a negative thing. How much is it going down by? 2 minus what equals -7? Well, 2 minus 9. And that's how we could have figured it out. Rather than actually looking at each point, you could have just looked at one set of points and then figured out the rest of them by adding 9 to the x's and subtracting 9 from the y's. So algebraic representation is x plus 9, because it's moving to the right, and y minus 9. What do you notice about the angle measures in the pre-image and the image? Do they change sizes? The angle measures do not change. They stay the same. So next, number 5, describe the translation. They want you to describe what's going on. So if I'm going from 12 to negative 1, that's the x, right? How do I go from 12 to negative 1? Am I going forward or backwards, right or left? I'm going down, right? So I'm going to left. How much am I going? Well, how do I get from 12 to negative 1? Well, 12 minus 13, because I'm going down to 0, so minus 12 plus 1 more. So x minus 13. So you're going to the left, 13. And then let's look at what's happening to the y. It goes from 7 to 14, so it's going up. How do I get from 7 to 14? Well, I go up 7. Describe this translation. So I could also say x minus 13, comma, y plus 7. That's the other way I could have described it. From negative 6 to negative 5, that is, I'm going up, right? So that's the x, and it's going up by 1. Up 1, or x plus 1. And then what's happening with the y's? From negative 8 to 2, I am also going, so not up, but, sorry, right 1. For the y's, what am I doing? I'm going from negative 8 to 2, so I'm going up. It's going from negative to positive, so I'm going up. How much am I going up? 8, 9, 10, so up 10. So y plus 10. Lastly, from O to O prime, let's see what's happening to our x's. Is it moving right or left? Is the number going up or down? The number goes down, so we're moving left. X minus from negative 3 to negative 6, so you're going down 6. So left 6. And 6 to negative 1, that is down. Down how much? Down 7. So x plus 6, y minus 7. And those are our two descriptors, the algebraic and the regular, just English way. So that is how we deal with transformations. We can express them algebraically or just in regular words. Remember, the pre-image doesn't have the prime, the new image, or the image has the prime on it. So go ahead and try some practice problems on your own. Good luck.